So in this video, we want to work on modeling and analyzing a 6-bar linkage for some dynamic response, such as displacements of these two triangular links in the linkage, as well as the forces that are applied to the points, the joints between, or the pins between each of these links. So we can get the force information and also the positions of some of these links that we can also plot in terms of x and y instead of as a function of time in working model. So I got this 6-bar linkage from a textbook, and I did some calculations to find all these dimensions. And because of some of the irregular angles between these points, some of these dimensions are to the 4th or 5th points after the decimal. I try to be as accurate as possible, because if some of these numbers are not very accurate, it could cause the linkage not perform as expected and give some errors in its motion. So that's why some of these numbers are a bit too accurate for a design, but I wanted to make sure that the linkage does not break during analysis. So these are the dimensions I'm going to be referring to as I design this 6-bar linkage in working model. So I'm going to refer to this picture frequently as I'm designing the linkage. So with that, let's go to working model. And again, like before, the first thing I have to do in my computer is to apply a pause control. When I come to world and go to pause control, I can create a new condition and copy and paste the code that I saw in that notepad. And this number 1 is the amount of time it takes for a working model to pause the analysis. So I'm going to make it 10 seconds, gives me enough time to see what's going on. And I'm going to press enter and OK it. Next, I want to turn off gravity, so gravity doesn't affect the performance of the linkage. So I go to world and gravity and change the type to none. I don't want any gravity. And I don't need to change anything about the dimensions because it's in meters, and by default working model works in meters. The only thing I want to change is as I'm designing this linkage, I want to work with degrees instead of radians. So in SI, instead of SI radians, I pick SI degrees, but then I can change it back to radians if I need to get velocities and accelerations, basically angular velocity and angular accelerations in radians per second and radians per second squared. But right now I'm designing it and I want to give my angles in terms of degrees, so I change it to that. The other thing I can do to make the designing and modeling this linkage easier is to go to View, Workspace, and then turn on Ruler. That gives me the dimensions, the distances, as well as the grid lines, so that I can see where I'm putting my links, and stick with that. So what I want to do is just to move a little bit to the left and right so that I can see the 0.00. Here is 0.00, and I can start designing now. So I want to create the ground link first, which is 8.43 meters in the horizontal direction only. That's the distance between this pin and this pin, L2 and L4 if you like. So I'm gonna create a rectangle trying to be as close to 0.00 as possible and create a rectangle like that, a horizontal direction. If I right click, I can see the properties, and I can also see the geometry for this thing. So as I can see in here, the height is 0.4, which is fine, and I want to pen this so that when I change its width from 8.6 to, it was 8.43, that was pretty accurate, almost. That is the distance between the pen, not that one, the pen here and the pen in here. And I'm going to remove this pen, make sure that I'm removing the pen, and I want to temporarily ground the ground, and I'm actually going to remove this link when I'm done with my calculation, with my modeling, so that I don't have to worry about this ground thing. So let's create the first link, or second link in to be more accurate, which is this one, L2. it is at 1.82 meters and 61.12 degrees in the initial position. So I'm gonna pin it first over here where it's pinned to the ground. It was 1.82 and 61.12 degrees. So 1.82 is the length and 61.12 is the initial angle. So that's where it has to be, and I'm gonna temporarily anchor it so it doesn't move as I make my other links. The next thing I want to do is to create the last link, the L4, which is 4.05 meters and at 103.15 degrees. And that starts from this point of the link. So I'm going to create that. I'm content with how it looks right now. I'm just going to pin it here. And then I'm going to give the dimensions. So let's go back again. It is 4.05 and 103.15. So 4.05, 103.15 degrees. And I'm going to anchor this one as well. So these two links were easy to create, not a big trouble. Now I have to create this link 3, which has its the pin for that is at this point at 4.45 something in the vertical direction and 2.877 something at the horizontal direction. So I'm going to create a couple guide links to get to this point, and then I'm going to remove them afterwards. So let's create a horizontal link first from here, and I want to pin it right there and then change its dimension to 2.877271, which is going to be difficult to remember. 2.877271. 2.877271. I think it was the length. Well, actually, it was pretty accurate over there. So from this point, which is the middle of this line, I'm going to zoom in a little bit. I have to go upward by a certain dimension, which I have to refer to the picture to remember, and that would be the point where I want to put the pin for that link. So the dimension is 4.45099. So I'm going to create another rectangle, this time in the vertical direction. So I'm going to start from here, and that was not as best as I wanted. So if I move it a little bit, that's not perfect. So let's see if I could make it a little bit better. All right. Oop. I thought I had got the snap in the middle. Okay, this is exactly what I want. So because this link is going to be deleted, I don't worry about its dimension at all. What I want to do actually first is to make sure that its width is twice as much as it has to be. So I say times 2. I did not like that thing, and it is now does not actually it does. So let's see if I can pin this end and this end, and let me also anchor this point. Let's see if I can change the dimension of this one to twice as much as it is. Right. So I can then remove these two pins. Make sure that I'm just clicking the pins and pin this link right here. So now I can change, zoom in. Okay, I can change its height to the height of this link, which is 4.45099. So 4.45099 is the height of this link. So here, the middle of this link is going to be where link 3 is going to be located. So what I'm going to do is anchor this one as well, so it doesn't rotate as I make my other link. And zoom in here. and try to put it as close to that center as possible. This time, actually, working model is snapping very, very well compared to the previous cases. So right now it's at 2.49 something or 0.249 something, the length of the height of this link. So let's make sure that it's twice as that. I'm going to pin up to here and here, and then I'm going to say the height is 2 times as much. And then I'm going to remove these two temporary pins and pin this link where it has to be pinned, which is right there. At this point, I can remove the temporary links that I had created, this one as well, and let me remove this and put another pin right there. Okay, so now I have to give the length of this link and its angle. So the length is 3.65 and angle is minus 59.12. So I actually forgot 3.65. Let's do one step at a time. 3.65, and the angle is minus 59.12. So minus 59.12. So that is where this will have to be. I'm going to anchor this one temporarily as well so that it is at the right location. It doesn't move. So the 3 links are created. Now I have to create 2 triangular links. The problem is that these 2 points here and here do not exist in working model. So I have to create 2 temporary points in working model as guide points, and then I can remove them after I'm done with creating the triangular links. So I'm going to create 1 point with these dimensions 5.178518 and then 1.318399, and then actually that point was supposed to be here, so I might have, let's see, maybe this should be correct. We can actually try this one, see if it works. If not, I'm gonna have to go back and figure out the correct dimension. So regardless, I can place a point by looking at this point element and place it somewhere like here, and then I can change its dimensions, or actually its x and y coordinates. So x is right now at 5.10 and y is at 0.40. So let's see, based on these dimensions, 5.1785, actually I bring it like this and make this one like that. Maybe I can use this to give the dimensions. So the x coordinate is 5.178518, and the y coordinate is 1.318399, which does not look where it has to be. So I apparently made a mistake in finding this distance, which is not a big deal. Let's save this one as far as we've done. I'm going to go to my documents and call this one 6-bar linkage. And I can show you actually how you can find the correct dimensions based on an original model. So I had done this before as well. I was practicing for this video. I'm going to open what I had done from desktop, the 6-bar linkage. So this is the point I was looking for, and apparently I did not find the correct values for that. So this point is at y of minus 0.05502, and so I have to remember that. And I'm going to temporarily remove the motor I had created in my previous model. I'm going to put a point in here. Then I can get the y coordinate. So the y coordinate of this point is minus 8. If I go to calculator, so 8. And let's go back here, and this one is minus 0.55, or actually that's not the correct number. Okay, I need to look at this link, and one of these 2 points will be the coordinate for that. So I believe this is the number. How do I find that number? If I click on this other orange link here, I need to find 10.9635, which this x is, and the corresponding y for that is minus 7.369 something. And if I click on this point, because on this red link, this point is shared, so I have to find the same x and find that appropriate y for that. So 10.963, 10.963. So this is the y that I'm looking for. So again, if I click on this, let me clear this. This is 7.369343. So this is the distance I'm looking for. Let me copy that and go to my working model and change the y to that number. All right, so that's where it has to be. And if I look at my picture, it looks at pretty much the right distance, I believe. Now I have to find this other point, or design this other point here, which is at 6.129718, and the height of 0.83 something. So let me move further a little bit here and bring back this picture side by side, create a point, and I need to do this so that I can see all the windows. And because I can't memorize these dimensions, I'm doing this, and then I'm gonna maximize the working model window. So the x component is going to be at 6.129718, and the y component is going to be at 0.838011. All right, so let's maximize working model, and I'm going to use these 2 points as guidelines to create the two basically triangular elements. So if I look at the first triangular element, it goes from this link to that link to the first point that I created. So let's create the first one. By clicking on the polygon, I can start from here, go to that middle point, go to the point, and come back to this. And because I create a closed loop that is properly defined as a link. And this point is the center of mass of this link that WorkML calculated for us. And I'm going to anchor this one as well. It's a good practice to anchor, because as you rotate things, it could, while you're modeling, it could change the orientation or the angles of each of these links, which is not what we want. So let's go to this part. Now I have to go from this point, the center point of this link 4, and the second point that we created, and the first point that I created. So I have to go from clicking on polygon, go from here to here to here, back to its origin. So with that, we have created the 6-bar linkage with a little mishap or miscalculations that we ended up with a little bit earlier. I'm going to save this, and I want to remove these anchor ones because now we are ready to start. Oops, I hope I can undo this. I want to remove the anchor, not the thing, and also remove these temporary points if I can. See if I do this, hopefully I can just select. All right, the other thing I've forgotten to do is to create the pins between here, these two links, these two links, these two, and these two. So I have to create 4 pins. So if I click here and go close, I should be able to snap and make those pins. And this one as well. So let me save this, and for the sake of testing, let me just see if I can rotate my linkage without it breaking or anything. And it did. So let me undo, start from the origin, so it works properly and as I wish. So I'm gonna remove this pin that we created, and I'm gonna replace it by a motor. And when I go to properties, I want to change it to a velocity of, let's go something at like 20 seconds or 20 degrees per second. And then I want to go to view numbers and units and change the units from SI degrees to SI radians in case I want to calculate the angular velocities and angular accelerations. For this example, I'm not going to do that. I'm going to do something different, but just in case you want it in the future, it's good practice to calculate or to measure your velocities in terms of radians per second and radians per second squared, not degrees. So I have the motor here, and I have all the links connected. We tested that it works. Now something else I want to do is, let's say I want to find the positions or the profile of the motions of 2 points along these 2 links. So I can click on this point element and put a point anywhere on either of these links or even the blue links as I wish. So let me put a link point right here. And because I put the point here, that is automatically attached to the triangular link which is underneath it. And I can do the same thing for this other triangle. Let's put this point right here. 2 random points, or it could be actually points that we care about. So just to make my point, to get my point across, is if I start rotating my input, but right now I can't because I put a motor here instead of a pin, these 2 points will have to move with that. So I'm gonna rename these, if I could actually get to appearance. So I'm gonna call this point point 1 for the lack of a better name, and the second point is going to be point 2. Then if I click on a point and save this first and come to measure, I can get its position, velocity, and acceleration. I'm interested in the position, so it would give me the x and y and the angular position, as well as this point, measure the position. That's one thing. Another thing we can do in working model is to change the accuracy of our calculations. So if I come to world and go to accuracy, I can change it from 0.05 second for delta time to 0.001, make it more accurate, and then have it run. So let's for now work on the positions of these 2 links. I'm gonna try this and run it, and after 10 seconds it should pause. As you can see, these 2 points that we created are moving with the links that they're attributed to. Let's keep running. So it makes at least 1 full rotation, which should be coming up soon. Okay, so I'm going to reset, save this, and right click on one of these 2 and do copy and go to Excel and paste these over here. So I have the time, X, Y, and rotation for point 1, and time xy and rotation for point 2. What I want to do is to take these points, the x and y coordinates of the first point, and get to insert and scattered and do a plot. So what this plot shows is the profile of that point that moves with that first triangular link that we created. So we can see that it just moves along this path, and at this point it crosses its own self. And then I can do the same thing for the second point, only selecting the x and y coordinates of the motions of the second point, and then I can come to insert and go to here, and now this shows me the profile of the point of the path that the second point covers as it moves with the linkage. So we can see this. The x-axis is the x and the y-axis is the y, and it also shows these titles which we don't need. Or you can decorate your links or your plots as you wish. You can also do this in MATLAB if you don't wish to use Excel. I'm just showing you how to use the x and y information from that to show the path that each one follows. And you can do this for any point. So if I just get the positions for these links, I can get those similar information and get them as well. The other thing I want to do if I remove this from here and from here, I can click on any point. In this case, I'm going to click on this point only, but this applies to all of the points that are in this link, and I can say measure and measure the force. And if I need, I can also measure, if I click on this, measure the torque for that. And let's also do for this point. So measure force and measure the torque for that point, if there is any to be calculated. And as I said, you can click on all of these points and measure the forces and torques for each one, but I'm just showing you like 2 points as an example. So let me save this and click run, and it's calculating as we expected. There is no torque associated with the points. So what I'm going to do actually is, after I'm done, I'm gonna pick one of the points, let's say this or the link, this link, and do measure, if I can find the force, the total torque. Let's see if we can get a torque. And one suspicion I have is that because I have a velocity only here, it might not have any torque, but let's run it anyway. All right, so we can see a torque at the center of mass of the link that we selected. So with that, I'm going to reset, remove these 2 torques. So I'm getting 2 forces and a torque. And let's run again so that we can get all of those information, and then we can import to Excel and then do as we wish with in terms of the dynamic analysis of the linkage. So it moves a bit further, and now we have kind of a full rotation. So if I click on one of these and do a copy, I can go to Excel and let's create a new sheet and paste it. So I have the force in the x direction, force in the y direction, and the magnitude of the force, which we could also calculate using these 2 components, and then the force for the second point, as well as the torque for one of the links that we created. And we can do, like, again, I can click or select this torque, for example, and I can do that with the forces as well, and then I can plot them as I wish, and that shows the torque as the linkage makes a complete rotation. So that's how it goes. One thing we have to do is to change this torque to a value at 360 degrees, or a complete rotation of the input link, which I have shown you before in a previous video how you can do that. I'm not going to spend more time in here and showing you how to do that, but that's the same way that we could we could change these initial values to actual values, not zeros. So in this video, I showed you how to design a 6-bar linkage, get the positions of random points on your links, and then plot the profile of those points like I showed in this sheet. And then also showed you how you measure the forces for specific points as well as a link, and you can also get the torque for links but not for the points in a linkage.